Hi there. In the previous video, we had a look at transformations of quadratic functions. And in this one, we're going to just have a look at some examples from the textbook from exercise 3D and see how knowing about transformations allows us to sketch graphs fairly quickly. So let's get stuck straight into it. We've got from 1e here in exercise 3D, we've got y equals minus x squared plus 4. So from our understanding of transformations, we can probably just have a bit of a quick check to see what this means. The minus means that we've got the graph, it's reflected. Okay, so we need to remember that. It's a reflected graph. The x has been squared with no horizontal translation. So remember that there are two translations. One is when you've got a minus h applied to the x, and the other one is a plus k. Looking at this one, there is no minus h, it's just x squared. Here's a minus h here. The plus 1 is basically that. This one doesn't, but it does have a plus 4 here. So it's been translated 4 units up. Okay, so we've got a reflection and 4 units translated up, and nothing else has been transformed. So that allows us to sort of generate some answers pretty quickly. Now for exercise 3D, we have to find the turning point, the axis of symmetry, and the x-intercepts so that we can sketch the graph. Interestingly, it doesn't ask for the y-intercepts, I don't know why. So when I look at the turning point then, the turning point was 0, 0 in the base graph. No horizontal translation, but a vertical translation of 4. And so the turning point must be 0, the base turning point, but now it's been translated up to 4. So that's not too bad. The axis of symmetry is really easy as well, I think. The axis of symmetry is just x equals whatever the x coordinate is of the turning point. X equals 0. Okay, now remember, x equals 0 is an equation. It's a relation, not a function, and it can be graphed. It's a vertical line. It's the axis of symmetry. It's not just a solution for x or something random like that. The x-intercepts are always worked out the same way. X-intercepts, we say let y equal 0. Therefore, minus x squared plus 4 equals 0. X squared equals 4. X equals plus or minus 2. So I like to write the points up here though. So we've got 2, 0 and minus 2, 0 as my 2 points. Didn't ask for the y-intercept, but I reckon we can figure out what that is anyway. So when I'm now, again, use a ruler when you can. So I know I'm being hypocritical for the sake of speed of this video. So there's my axes. I've got my x-axis, I've got my y-axis. My base turning point, which was here in the middle at the origin, has now gone up 4 units, like so. So that's 0, 4. And then it's reflected. I know that, so it's going to be a frowny graph, and I know it's going to be going through minus 2 and 2. Remember, it is always symmetrical, so it should look nice and symmetrical here. So I'm just by eye trying to go about halfway between 0 and 4. Now, I can't show you this in the video, but I'm not going to be able to do this very well because my screen is a bit grippy on my hand, so I'm not a very good drawer of parabolas anyway. But the best way to draw a parabola is to actually move the page as you're drawing it to get a nice smooth arc. This will not be an example of this. See, I missed the 2. But there you go, that's not too bad. So now I've drawn my axis, and the axis of symmetry I could put in if I wanted to. It's a bit boring here, but I'll just do it in a different color. So that's x equals 0, and there's the axis of symmetry, and we're good to go. Exercise 3D, question 2C, that's on slide 19 on this page. We've got y equals negative x plus 1. Again, a bit of a step back and have a look at what transformations we've been dealt here. We've got a negative here, so we know it's going to be a frowny graph. Okay, it's been reflected. We've got an x plus 1, which means we've translated to the left by 1. Remember, it's x minus h, but we've got a plus 1 here, which means we're going backwards. And there's no vertical translation. So what have we got here? We've got the turning point. It's usually, the base graph says 0, 0, so the new one is going to be minus 1 and then no translation to up or down, so it's -1, 0. The axis of symmetry is going to be x equals -1. It's just the x coordinate of the turning point. And the x-intercepts, just the usual, let y equal 0. Therefore, we've got -x plus 1 all squared is equal to 0. Now, that negative is irrelevant. I can multiply both sides by -1. I've got x plus 1 squared equals 0. I can square root both sides, and I've just got x plus 1 equals 0. And I've got x equals -1. So this is an example of just one x-intercept, and that's totally legit. Remember, with the quadratic, we can have 0, 1, or 2 x-intercepts. Okay, I'll just draw my axes, x-axis, y-axis, like so. And now I will put in my turning point, which is -1, 0. So let's say that's here. And I can now draw that. I've got my axis of symmetry. If you want to, you could draw that in if you want to, like so. That's x equals -1. And because I consider the x-intercept is just at -1 as well, it kind of makes sense now. It's going to be like so, symmetrical like that. Again, mine's quite wobbly, but you get the idea there. I don't like the fact I don't have the y-intercept, so I could just quickly substitute that in to see what I get. It's probably completely dodgy the way I've drawn it though. So I can go let x equal 0. Therefore, y is equal to -0 plus 1 all squared, which is equal to -1. So technically that's supposed to be -1 there. Excuse me, it's not, but it's good to label it, I think. By the way, it's not a bad idea to actually label your points with the actual coordinates rather than just, my natural thing is to just put the numbers on the axes, but they should be written as coordinates. It kind of makes it a bit better. Okay, one last example and that will do. So this one here, 2 means that it's going to be vertically squished. It's going to be thinner, but it's also positive, which means it's not going to be reflected. I've gone back by 2, x plus 2 all squared, so the plus 2 means I've gone back by 2, and I've gone down 18. So let's get into it. Number 1, the turning point is going to be, instead of 0, 0, I've gone back 2, I've gone down 18. For the axis of symmetry, for what it's worth, x equals -2. For the x-intercepts, as usual, this is where the hard work is. Let y equal 0. Therefore, I've got 2x plus 2 all squared minus 18 equals 0. Add 18 to both sides to get that. Divide both sides by 2 to get that. Square root both sides to get plus or minus 3. And therefore, x is equal to -2 plus or minus 3, which means it's equal to -5, and -2 plus 3 is +1. So my 2 coordinate points here are -5, 0, and 1, 0. So that's -2, -3 is -5, and -2 plus 3 is 1. Okay, so I've got my critical points here. I can now draw it, and I'm just doing this pretty roughly, as you're familiar with now. That's my x, that's my y. I've got x equals to 1 for one of my intercepts, so I'll put that there. And -5, so distance of 5 away. That looks okay to me. -2 minus 18 is where the new turning point is. So that's going to be, I don't know, I'm not going to do a very good job here. So that's -2 minus 18. So far, everything is kind of shaping up quite well. It's supposed to be a smiley graph because I haven't reflected it. I can see that it's going to give me that shape, so it's all sort of making sense to me. Just using those transformations to confirm that your calculations are correct is a really good way. Now, I'm going to, again, I can't do it, I'm not a very good drawer of them anyway, and I can't draw very smoothly on a glass surface. So apologize for this awful graph. That's absolutely awful. If I was doing this for real, I'd delete that and do it again. But for the purpose of this video, I'm not going to bother. I don't like the fact we haven't got that. So I'm going to do it over here. So that gives me y equals 2 outside of 0 plus 2 all squared minus 18. I'll do this in my head a little bit. 2 squared is 4, 4 2 is 8. So I've got minus 8 minus 18 is negative 10. So it's 0, negative 10. So I'll put 0, negative 10 here. This is 1, comma 0. This is minus 5, comma 0. And if you want, you can go for an axis of symmetry of x equals negative 2. That's a really dodgy graph. I'm so sorry. I feel embarrassed for leaving it there, but I will leave it there rather than trying to fix it up. But if it were you, I would be doing that again. But again, yeah, move the paper around. It's really useful for getting a nice smooth curve. Okay, I'll leave these examples here and I'll catch you next time.